Hi, welcome to Module 3. This is Part 5. So now we're going to talk about measurements of temperature. And so basically, to measure the amount of activity a molecule is going through within its form, we would take its temperature. It's just measuring how active the molecules are, but in response to that, it's determining how much energy is in a given place. So higher temperatures have more energy, lower temperatures have less energy. It's just the form of the energy at this time is thermal energy. One of the key instruments that we use to take a temperature is a thermometer. And I know this seems like a go figure, but thermometers, obviously in the United States, we prefer to use a Fahrenheit scale, which is kind of a wonky, sloppy system. In the rest of the world, they basically use the System International, which is the Celsius scale. The way we like to take that temperature is in one of these little temperature shield boxes. And the point of these is to create an area that is about 5 feet in height, and that is because the temperature at the ground can be incredibly variable. It can be 20 degrees warmer on the very near surface to the ground than compared to the temperature up around our heads, around 5 feet to 6 feet in height. So we like to take temperature at about 5.5 feet, and we build one of these shelters that blockade a little bit of wind, and we will place our instrumentation in here to do things like take temperature and some humidity readings and so on and so forth. Temperatures range, there is different terms, but basically you have a daily mean range, which is my highs and lows for the day. Oftentimes the coldest point of the day will be right before the sun comes up. Then the sun comes up and the temperature will often begin to rise if there are no clouds, right? And my peak temperature will be sometime after peak sunlight. So when sunlight has met its maximum extent of being most directly upon the surface of the earth in a particular point in time, sometime about an hour and a half lag after that, I will meet peak temperature. And that's because at that point, everything that was absorbing sunlight will also be sharing sunlight, and it's the bombardment of both incoming solar radiation and the sharing of thermal radiation from whatever has absorbed that sunlight and transferred it to heat. And that combination creates a bump or spike in temperature. As the sunlight begins to fade and the sharing begins to meet equilibrium with the things around it, we see a drop off in that temperature, right? So that's my daily mean temperature. I can have what's called a daily temperature range. This is my high and low for the day. This is what you typically see in any news report. Monthly mean, this is your average temperature over the course of a month, right? And then annual mean, which is the overall annual for the surface of the earth. And this one's important, especially when we talk briefly about global climate change, and then I'll do a whole special PowerPoint set on global climate change. But one of the key things that we talk about when we say that the earth is warming, we are saying that the overall mean temperature of the earth is warming. So if I take everything and average it out over the course of the year, the overall temperature is warmer. That doesn't mean at any given place, at any given time, I can't see extremes. And that's actually what we're going to see. As our climate begins to shift and alter to try to accommodate all this additional energy source that's being absorbed into our atmosphere because of the thickening of our greenhouse gas layers, we will continue to see really extreme events. So there'll be a lot more energy, since there's more energy available within our atmosphere, we will see a lot more extremism. And everything that we once knew and measured is no longer true because the amount of material that can absorb light energy and transfer it into other energy forms is in greater amounts. And so there's more available. So what used to be true will not be the new normal, and that new normal is constantly changing because we are increasing the number of fossil fuels in our atmosphere. So everything just keeps increasing up. So on that note, we have global extremes, and this is just talking about places around the world, and it's kind of fun to note. We consider the world high and world record lows, and if you haven't been following things like the NASA Climate Energy Information, one of the key points that we've gone on is that the warmest 10 years have been in the last 15 years. So we've seen some really extreme conditions in recent history. Which brings me to the last thing I'm going to cover for this semester or for this module, and that is the heat index and wind chill index. What am I measuring and why is it important? And I'm going to actually flip right to the wind chill and heat index images that I have, because that's going to be much, much easier than trying to explain it to you without these images. And you're going to work with these in your lab module. So you'll see these in lab module. So starting with heat index. The importance of the heat index is that when I add water to the atmosphere, because water is a good absorber of heat energy, right? High specific heat capacity can hold that heat in. It means that the temperature around me, even though it may be cooler, it is actually something that my body will react to as being warmer. So the heat index is actually a measurement of how your physical body is handling or reacting to that temperature. So for example, if I say that the heat index today is 119, which means that the actual temperature outside is 104 and the relative humidity was 40%, what I'm actually saying is that my body is acting like the outside temperature today is 119 degrees with no humidity, no moisture. So the combination of those two things will make your body react a certain way. It makes your cells react a particular way. And that's why it's so important. This is why it's so dangerous. So please don't ever ignore heat index. When somebody tells you that the heat index says, that's what your body is reacting to. That's what your body considers that temperature as. So your chances or risk of things like heat stroke becomes exponentially greater if you take into account these relative humidity numbers. One of the things you need to be able to do is just compare those. So if I said today's temperature is 88 degrees and the relative and the relative humidity is 60 degrees, the way I do this is air temperatures on this side, right? So I take my 88 degrees and watching my cursor again, my relative humidity is up top here. And I'll take my relative humidity at 60 and I line up the two numbers. So here's my 60, there's my 88, which means that the temperature or the relative humidity temperature, the temperature of the heat index out today is 95 degrees. And if I take that, then compare it to my little potential caution risks, it says that my caution risk would be extreme caution. I could be prolonged exposure can lead to sunstroke, muscle cramp, and or heat exhaustion is possible. So you need to be able to utilize these charts to answer questions and also understand what they mean and what they measure. Some trick questions that I might ask you on something like a multiple choice would be something like, what does heat index measure? It measures the relative humidity and air temperature. It does not take into account what the next index measures, and that is wind chill. Wind chill is what we utilize when it's cold outside, and that is because when there is breeze happening, it actually pulls the heat away from your body, and because of that, your cells feel as though it is colder out than it actually is. So while the air temperature may be only 35 degrees outside, the wind chill comes in and has a factor on it, making it actually feel colder. And that feeling is very real. It's not some like you're being a wimp. It's a real thing. Your body cells are reacting to the same conditions as if they were just standing in those conditions. So if it was 35 degrees, for example, and the wind was gusting at 50 miles per hour, I take that number and it is 19 degrees wind chill. That means that right now outside, my cells are reacting to 19 degrees wind chill, or it would be the same reaction as if I was standing outside with no wind at 19 degrees Fahrenheit. So it is the same body reaction when I add the wind to the temperature, and that's why it's key. Once again, you have to be able to utilize the chart. So let's say it's a freezing day at 0 degrees and the wind is gusting at 30. So I line it up and line it up with the 30 and I get negative 26, which would mean I could have frostbite on exposed skin within 30 minutes. So those are the things you need to be able to do, and that's what I consider covering this chapter. I know that there's quite a few slides. If you have any questions, once again, always post in the discussions and make sure you do your weekly discussion posts. Take care. Bye.